Yes, so let us start this session. Hope am I audible, right? Please let me know in the chat box. Okay, great. So let us start this session. One second, give me 1 second. Let me share my screen. Is my screen visible? Yes, I hope my screen is also visible. So let us start this session. Um, it's we have got a gap. Okay, it's not a problem. So let us try to be consistent. In the upcoming days. I will try to. I think my works has little bit reduced. Yeah. So what we have discussed, 1 second, let me open the relevant PPT. Where is it? Yes. So coming to the previous sessions, we have started our discussion regarding the priority encoder. We have seen the priority encoder, and we have also discussed about the encoder, and we have discussed about priority encoder. And we also discussed about demultiplexer and we have derived everything and multiplexer related problems also we have done a lot in our previous sessions, right? Yes. So in this particular session, let's first of all discuss about priority encoder circuit, like how to develop the priority encoder circuit. And I think that particular thing I have given as an assignment. Hope everyone has done that particular assignment. Now let us try to come up with the circuit for the priority encoder. Okay. Now, this is the truth table of my priority encoder which I'm going to have, and I need to first of all come up with the minterms for y1 and y0. This is what my task is at present. So how to come up with the minterms for y1? So you can see y1 is having the minterm. Okay, this is not the priority encoder. This is normal encoder, I think. Let me first of all draw the priority encoder truth table. Okay, I've drawn it. I've expanded it. That's it. Okay, so let me draw the priority encoder table again. I1, I0, Y1, and Y0. So you can write down 0, 0, 0, 1, and 0, 0, 1x, and 0, 1x, and x, and 1 triple x. Okay, these are the different cases which we are going to have. And this is equal to 0, 0, and this will be equal to 0, 1. This will be equal to 1, 0, and this will be equal to 1, 1. Okay. So this is nothing but my priority encoder table. Now I need to get the minterms. Now, how to get the minterms? So for y0, let us try to take the minterms first. So y0, if you carefully observe, you have x over here. Okay. So if we are going to have x over here, how to take the minterms? It's very simple. So substitute x is equal to 0. If x is equal to 0, it is nothing but 0, 0, 1, 0, which is nothing but 2. 2 is one of the midterm. And next is 0, 0, 1, 1, which is 3. 3 is one of the midterm. Okay. So y0 has midterms 2 and 3. This is one scenario. And here also you have 1 triple x. So 1 triple x, if you expand it, you are going to have 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So these are the different midterms which we are going to have. Starting from this is 8, 9, 10, 11, 12, 13, 14, 15. So 2 comma 3 comma 8, 9, 10, 11, 12, 13, 14, and 15. These are all the midterms. It's not don't case. So many people write them as simply don't case. Please don't write it down as it. It's these are all the midterms which we are going to have. Okay. And this is nothing but the midterms for y0. Coming to midterms for y1. So coming to midterms for y1, again the same method. So 0, 1, xx we are going to have, which if I'm going to expand it, it is nothing but 0, 1, 0, 0, 0, 1, 1, 0, and 1, 1. Okay. And starting from 4, 5, 6, and 7. So 4, 5, 6, and 7. And next what I have is 1 triple x. 1 triple x is again from 9 to 15, which I'm going to have is nothing but my 1 triple x. From 9, 10, 11, 12, 13, 14, 15. Okay. So these are the minterms for my y0 and minterms for y1. Is it clear, guys, how I'm going to take the minterms? Yeah. So generally, this is the most confusing part because we see don't care and we write down don't care in we write like this. We consider them as don't care. So please don't consider them as don't care. These are midterms only. Okay, you need to expand it. That's it. Okay. Now using this midterms, you are going to basically calculate or you are going to simplify using the key maps and you are going to get the simplified Boolean expression. So for that, let's see the simplified Boolean expression. One second. So coming to y0, it's a function of I3, I2, I1, and I0, where I3 is your MSB and I0 is your LSB. Please be careful about it. So I3 is your MSB and I0 is your LSB. I'm simplifying it. Anyone has simplified? And can you let me know the answer which you are going to get if you have simplified it previously? I1, I0 complement, I1 complement I0, I1 I0, I1 I0 complement. Anyone has simplified it previously? I think I have given this as an assignment. I3 I2, I3 I2, I3 I2 complement 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, and 15 and 14. Okay. So coming to this midterms, I'm going to have 4, 5, 6, 7, 9, 10. 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. 11, 12, 13, 14, and 15. Okay. So these are all the midterms which I'm going to have. So let's search for the octet or let's search for the quad and all. 1, 2, 3, 4. This is quad. Okay, let me change the pen color. Actually, it's very confusing over here. So 4, 5, 6, 7. Okay, this is one quad I'm going to have. And 1, 2, 3, 4. This is also one quad. And what else we have? 1, 2, 1, 2, 3, 4. This also we can group it. And this is one more quad. And this is one more quad. I'm getting this many quads. Okay, I should once check it out. Anyone has previously solved it? Are you getting the same number of quads? Or are we doing any mistake over here? Okay, we can make a octet, right? So why are we wasting? Okay, one second. This is one octet. And 1, 2, 3, 4, 5, 6. We cannot have 6. We'll make one quad over here. That's it. Okay. I'm getting this. And so if I make this group, then it is what is the common term over here? I3 complement plus what is the common term over here? I3 into the common term in this I3 into I1. Okay. This is what the expression I'm going to get it from y0. Okay. Next, same you can do it for y1. Okay. Same you do for y1 using the key map. And please let me know the expression. Okay. This is a small assignment for you. Just calculate for y1 and let me know it. Okay. Yes. So after solving this and let me know in the expression, we will discuss like how exactly the priority is being working and all. Okay. Yes. So any doubts or any queries in the priority encoder? Please turn off your video. Someone has turned on their video. 1 second. Yeah, please be careful when you're attending online meets. Yes. So coming back to our discussion, is this clear? Any doubts or any queries in this particular discussion? And anyone has solved for Y1 also? Hello, am I audible? Okay, yeah. So please try it. You have solved Y0, right? Solving for Y1. Okay, okay. Yeah, Akshit. Sure, sure. So you can take as your assignment and you can solve it and let me know the expression which you are going to get it for your Y. Okay? Yes. So let's move to decoder. So after discussing decoder, we have some set of problems to discuss, and we will discuss this decoder problems after discussing a few things about decoder. Okay. 1 second. Let me add it over here. So decoder is completely opposite to your encoder. Okay. So encoder is going to convert 2 power n inputs to n outputs, whereas your decoder is going to convert n inputs to your 2 power n outputs. It's completely opposite to your encoder. Okay. Now, where if let's say suppose n is equal to 1, I'm going to have 1 cross 2 decoder. And let's say suppose n is equal to 2, I'm going to have 2 cross 4 decoder. And n is equal to 3, I'm going to have 3 cross 8 decoder. Okay, depending upon the value of n, I'm going to decide what kind of decoder I'm going to work with. First, let's see about this 1 cross 2 decoder, where I'm going to have one input and two outputs. This is Y0 and this is Y1 and one input like this. Okay. So coming to this n is equal to 2, I'm going to have two inputs and four outputs. Y0, Y1, Y2 and Y3. And I'm going to have only two inputs, I0 and I. So first let's see the truth table of this 2 cross 4 decoder. So 2 cross 4 decoder, I1 and I0, Y1, Y3, Y2, Y1 and Y0. Okay. Now, so if this I1 and I0, if it is equal to 0, 0, then this Y0 will be equal to 1 and remaining all will be equal to zeros. Okay. Now, if it is equal to 0, 1, then only this Y1 will be equal to 1 and remaining will be equal to zeros, and 1, 0, only this Y2 will be equal to 1 and remaining will be equal to zeros, and 1, 1, Y3 will be equal to 1 and remaining will be equal to zeros. So depending upon my input, what kind of input which I'm going to provide, I'm going to get the output. And you can see in the case of your decoder, at a time, only one particular output is equal to 1. Okay, this is the case of your 2 cross 4 decoder. Whereas in the case of your 1 cross 2 decoder, if your input, if it is equal to 0, y0 will be made to 1 and y1 will be equal to 0. And if your input, if it is equal to 1, y0 will be equal to 0 and y1 will be equal to 1, depending upon the input only. Okay. This is how your decoder is going to work. Okay. Now, from this table, we can easily get the minterms. So, y0, can anyone say me the minterm for y0 and can anyone say me the minterm for y1? You can see over here. Y0 is nothing but input complement and y1 is nothing but your input. Okay. So this is nothing but my 1 cross 2 decoder expressions. And over here for 2 cross 4 decoder, you can get y0 easily. So y0 is nothing but I1 complement into I0 complement, and for Y1 it is I1 complement and I0, and Y2 it is I1 and I0 complement, and Y3 it is I1 and I0. Okay. So this is how you're going to get the expressions for your outputs of a decoder. Okay. Yes. And these are decoder is a very easy thing which we are going to use, but the problems are very good on this particular decoder. And you might get some questions like implement a half adder using decoder, or implement a full adder using decoder, or implement some kind of random Boolean expression like function, or implement some in terms 1, 3, 4, 5. Implement this particular function using decoder. So this kind of questions you might encounter. And this we are going to start our discussion in our next session. And yeah, and also we are going to start discussion about this particular problems also. I think we have still time. Yeah, we have time, so we can start with this particular problems. So first of all, tell me whether this decoder is clear. Okay. So yeah, so let's start with this problems. So you can take your time, solve this, and let me know the solution for this. So this is the very first question which we are going to have. We have been given with a 3 cross 8 decoder, and we are basically asked to find out what is the function f of x2, x1, x0. So you can take 2 minutes of time, try to solve this, and let me know in the chat. Your time starts now. So in the following circuit, the function f of x2, x1, x0. Please look into this carefully. They have clearly mentioned x2 as the MSB and x0 is LSB. Okay. So please act carefully. X2 is your MSB and x0 is your LSB. So please don't consider this as MSB and do the problem. X2 is your MSB and give the answer accordingly. And x0 is your LSB. So the question is, in the following circuit, the function f of x2, x1, x0 is. They are basically asking what is the output, and they have given a 3 cross 8 decoder with inputs x0, x1, x2, where x2 is MSB and x0 is LSB, and they are asking what is the function f. That's it. Simple question. Okay, let me also solve it parallelly. Let's see what is the answer for this. So you can see D0 is being connected, and D3 has been connected, and D6 has been connected. Only these three outputs have been connected to a NOR gate. Okay. Now, what is the expression for D0? D0 expression is x2 complement into x1 complement into x0 complement. How we are getting this? From the previous discussion. Okay. So this discussion we have done right on the decoder. So Y0 is I1 complement, I0 complement. It's a 3 cross 8 decoder where Y0 is I2 complement, I1 complement, and I0 complement. Okay, X2 complement, X1 complement, and X0 complement. And D3. D3 is nothing but, okay, here when you are dealing with decoders, one trick you can use is you can just write down the midterms. That's it. So D3, write down the midterms in expressions of inputs. So what is D3? X2 complement x1, x0. And what is d6? D6 is x2, x1, x0 count. Okay. So these are the different expressions which are given to the NOR gate. Okay. So just need to solve it. That's it. So let us solve this. Let me erase this. So y is equal to, we have x2, x1, x0 complement plus x2 complement x1, x0 plus x2 complement x1 complement x0 complement. And it is given to a NOR gate. So I'm going to have a complement over here. Okay. Now y is equal to, this is nothing but my minterm m6 plus m3 plus m0 complement. Can anyone say me what is the result? M6 complement plus M3 complement plus M0 complement. What is the result? This is nothing but sigma M 036 complement. What is that we are going to get? Option A, which is nothing but pi of 12457. Okay. Yes. Which is Mach terms of 1, 2, 4, 5, and 7. No need to solve this. If you solve this only, if you solve also, you're going to get the same. Okay. Yes. Is it clear, guys? Others also getting option A? Please look into it. Okay, great. And we'll discuss the other questions in our next session. Yes. So that's about this particular session.